Video will serve as a review of solving systems of equations using all of the methods. So the first set of problems that we're looking at here, you're given three different systems and you have to choose which method makes the most sense for each system. Now, of course, all three methods work for all three systems, but certain methods lend themselves better to some systems than others. So when I look at this, it's clear that set B, system B, is definitely best solved by elimination. Here, with this particular system, no coefficients are isolated. All of the coefficients are numbers other than positive or negative 1. So this is definitely a system that should be solved by elimination. When I look at system A or system C, A or C, analyzing these, either one of these could be solved by graphing or by substitution. And in system C, graphing or substitution. But looking at this closely, if I look at the second equation right here, when I isolate the y in this equation, I think that this would not be a good y-intercept for graphing, -5/2. So I would think that this particular system, system A, would best be solved by substitution. So I would solve this system using the substitution method, and I would isolate the x in the first equation. So I would isolate the x and let this be -2 plus y. I would make a substitution of that into the second equation and I would solve. And then let's look at system C. Looking at the last system here, system C. Cleaning this up for graphing, and I'll let you graph this on your own. But if I take this first equation and I isolate the y in the equation, divide both sides by -3, this gives me a y-intercept of -6, and that's going to be easier to graph than the y-intercept that we got in system number A. And then the second equation, both y-intercepts are easy to graph by hand, so system C would be best solved by graphing if you have to choose one method per the three systems. And I'm going to do one example of substitution, one example of graphing, and simply because I feel like elimination should be the type that's most familiar to you. So for this video, I am going to do number 3 and number 5. So number 3, graphing. Zoom in a little bit on this. So system, problem number 3, I'm going to do the graphing method on this particular problem on the video. I'm going to take that first equation. I'm going to isolate the y in the first equation. And to graph that line, I start at +1, and my slope is -2. Looking at the second equation, when I isolate the y, so this line has a slope of +1/2 and a y-intercept of -9. And my slope is +1/2. There's my solutions there, my solution point right there. And here the two lines would intersect. So I would be solving this by graphing. They're going to intersect at the point x is 4, y is -7. So just to review graphing. It's probably easiest for you all to graph in slope-intercept form, so I would isolate y in each equation. Or I would isolate y in each equation, graph the lines, look for their intersection. And remember, just as a quick review, when you're graphing, if the two lines are parallel, that's your no solution scenario. Or if when you simplify, it turns out that both equations represent the same line, that's your infinite solution scenario. And let me do one substitution problem on the video, and then we'll look at all the problems quickly, and I think you'll be fine with this. So looking at number 5, you're asked to solve by substitution. The first x in the first equation is the easiest to isolate. So I'm going to subtract 3y from both sides. I'm going to copy the second equation. I will replace the x with the expression that I isolated in the top equation. So I take one equation, I isolate the variable, and I make a substitution into the second equation. And now I clean this up. Combining like terms, subtracting 36 from both sides. And then for this particular problem, y ends up being positive 3. I go back to either original equation to find the value of x. And I'll just use that first equation. And since y is positive 3, I have this equation to solve. When I subtract 9 from both sides, x is 0. So the solution to the system in number 5 is the ordered pair x is 0 and y is 3. And just looking back at the entire study guide for a minute before I end the video. It starts with, I've already discussed this with you, choose a method, one method for each of the 3 systems. You get a little review with graphing and then some review with substitution. And looking at these really quickly, here the y is already isolated for you in the first equation. And the second system, or system number 4, I would isolate the x. And in system number 5, I would isolate the x right here. And that would just be 12 plus 4y, and then make a substitution into the first equation. Here, that's already isolated for you. With elimination, this is already set up for you. You would need to, you could either multiply the second equation by -1, or you could multiply the first equation by -6. You can solve and eliminate the variable of your choice with that. And looking at these, all of these are lined up. All your x's and y's and constants are lined up, so there's no rearranging needed for those. Moving to the next page, here you've got graphing, and I've already discussed that with you. I think your graphing skills should be pretty good. I did number 5 and number 6. I would isolate the y in this equation and make a substitution into the first equation. And looking at number 7, I would isolate the x in the first equation and then make a substitution in the second equation. Here I would isolate that x and make a substitution into the first equation. Add 6y to both sides and then make a substitution in the first equation. And looking at the elimination problems, it looks like everything is really straightforward. In number 12, you need to do a little bit of rearranging. Actually, this will be a good candidate for substitution. And if you want to, you can just go ahead and solve it by substitution since the x is already isolated for you. If you wanted to solve this by elimination, then I would simply take that first equation and subtract 2y from both sides and rearrange it like that, and then match it up with the second equation and solve by elimination.